Okay, good day, Dumelang, Salmonan, Abshin, Lekai, Tobela, Makadi, and this is again another installment in Comsoc 1, Book 2 for Week 2 work. We are looking at study unit number 7, coal mining hazards. And I know from the guys in Pumalanga, this is your cup of tea because this is your daily work. So we're going to be highlighting a few things in coal mining, particularly the hazards that are involved in coal mining, and explain to those who don't know what coal mining is involved in or involved with. So the following objectives also should apply over and above everything else we're going to discuss in this installment. Objective number 4, what should be checked on conveyor belts and coal mines? We give us 4 for 4 marks. Objective number 5, describe the main hazards in coal mine, 3 marks. Objective number 6, how can coal dust explosions be prevented, for 4 marks. And objective number 7, how does a manager know that all underground workings have been examined by the miner, for 2 marks. Those are the objectives that are very critical in this study unit number 7. So let's quickly go through the presentation and explain a few items. Let's put our pen there as well. And let's look at the methods. Coal mining involves 2 methods that are actually utilized to extract the ore: surface or open cut mining and underground mining. Now, in surface mining, let's start explaining the open cast mining. The sequence of operations involves the removal of topsoil. Mostly this involves using one of the biggest pieces of equipment you'll find in a mine, known as a drag line. I'll show you pictures of what a drag line is all about, because remember, a drag line in coal mines it's a critical parts equipment. Why? Because if it's not running, you won't be able to open new ground as well. So that's the removal of topsoil. Once that has been removed, it's all about removal of the overburden. Overburden, it is that bedrock over just underneath the topsoil. So then sometimes drill and blast it out, and then that is the process by drilling and blasting and loading. That's how you remove the overburden. And then it is a matter of loading the deposit, because most coal is not that deep, but there are seams that are rolling and rumbling, the seams. So that's how they extract. I'll show you a picture now of what I'm talking about. Once everything has been extracted, the seams that they want, and depending on the quality, and if the ore has been depleted, it's a matter of rehabilitation, covering the land to exactly how it was before mining started. Because what happens is, you can have, I'm sure you have seen farms and farms in Pumalanga, and suddenly they start mining to extract the coal. They pay insane amounts of money to lease that land from the farm owner. Then they go in and they extract the ore body after whatever period of time, and then they rehabilitate it exactly the way they found it. That's why we have the rehabilitation fund, isn't it, with the DMR. And then they hand back the land to the owner. I remember, if you are familiar with the Witbank, Tweefontein area, there by Tweefontein after Ochis, we used to have a venue there. There was a nice, beautiful golf course that we used to use at Tweefontein. But I think 2010, 2011, they came in there and said, there is coal underneath this golf course. We want it. And right now, if you go there, it's a big fledgling mine that is extracting the ore deposit from that area. So that's open cast mining for you. Then in open cast mines, this is a typical example of what we're talking about. You can see the removal of topsoil put on the side, the overburden, and the exposed coal deposit that they have to extract. Once that is done, if this stretch is open and extracted, so it's a matter of taking the overburden, filling it here in the hole, and then going again, extracting another batch again, taking the deposit, the overburden, and filling it in here as well after they extract. The same thing that they would have done here, and until they close everything up. So it's how they extract and exploit the ore deposit. This is a typical example of what a drag line looks like, and I'll show you one, a small little one in operation now in the presentation. These machines are quite big. There are some that are operated that have got 3 operators. One operating the boom, one the axle, the axle. One is operating the movement, how it moves. It doesn't have any wheels. It doesn't have any caterpillar chains, so to speak. In the biggest ones, that is, they have hydraulic legs. Actually, they can walk. They can walk it. I'll show you also one with caterpillar tracks, the smaller one in operation. Then you can understand. There are claims also of some with this kind of a bucket that you can park even 7 taxis, minibuses in that bucket. That's how big. And also, if you look at this boom, if you put it on the ground, it is, in some of the big ones, it is equivalent in length to 3 rugby fields. Put one next to the other. So that's the bucket. You can see the scraping or the loading. It's the same technology we use also underground, but in underground environment we call it scraper winches, because we are it's a matter of rigging with the bucket scraper to load and to clean out the ore. So this is a typical example of what this piece of equipment works and looks like, and this is a smaller version. Okay, as you can see, such big equipment, the rigid dump trucks, massive pieces of equipment. Look at that shovel, the size of that shovel. In here you will see all 3 pieces of equipment. You have your drag line here. You can see part of the boom, and central to the exploitation of coal in an open cast mine. But these pieces of equipment, as much as they're expensive and massive and huge, they are very dangerous. This was an accident whereby they called the guy that, listen, you ran over a bakkie, and he did not see it, because if you're in that cabin of that massive dump truck, you have got at least 100 meters radius for vision. Anything inside that radius you cannot see, even depending how big it is, even more in some instances. That's why today they are incorporating PDS systems in the machinery. They are incorporating cameras in the machinery, not only for the operator to check their fatigue levels, but also to assist the operator to see their surroundings. There is another typical example of a 785 that went over a bakkie as well. Look at the size of that tire. You can imagine how much each truck costs. Or how much each tire costs. You're looking at $500,000 to $1 million in one tire alone. That's a car. You can buy cars there with those tires. Size of that. You can see the passenger, the driver is still strapped in there. There's no chance. The operator of this piece of equipment, when he runs over that kind of a bucket, they don't feel nothing, because everything is on air suspension. Now, underground mining exploitation, the methods of mining involves what are known as conventional mechanized mining, which we're going to describe as we go along, continuous miner operations, long hole mining, and pillar extraction or stopping. This is your continuous miner operations, this piece of equipment that they use underground to extract the pillars. So that this drum is rotating, and you can see these tungsten teeth, they're actually ripping on the face. So it is cutting on the face. And you see, please take a look at the coal mining video clip that I have put in the folder as well. It will show you these machines in operation. So the coal drops on the tray here, and with this arm and this arm, what we call gathering arms, they are busy pulling the coal towards the back, where inside here there is an armored conveyor belt that goes right out through to the back. At the back there will be a shuttle car parked at the back, being loaded by the armored conveyor belt. So it's going back and forth. It's always behind the continuous miner. as it is filled, then goes to the tip and comes back. Now, most of this equipment is electrically powered. Talking about 1,000 volts going into one piece of equipment. So that's they use a lot of electricity, quite dangerous. Even the shuttle cars, you find they've got a cable, spooling cable, okay, at the back, and they go back and forth, so it unspools and spools around. It reels and unreels around. Even the employees and everybody else who walks underground, you are told, if you see a cable of a shuttle car that is working in one side and you're walking in the other side, you don't walk and straddle it, because at that particular moment it can jack up, it can whip up, and you don't want that between your legs. So normally employees are taught to step on it as you are going across in wherever you're going. This is a long haul mining system. I've got another presentation inside this presentation that shows how it works. You can see the cutter, the cutting drum, and you can see the wall. So this thing can cut from this end towards that end to the end. They are reported to cut on a face 250 meters one side, going one side and coming back one side. You can see the chocks and shields. These are the shields, the chocks with the hydraulically operated cylinders for support. So as they are cutting and advancing, going, well, that's the mining advanced direction, going this way, you can see the roof is collapsing at the back, and the guys are actually protected. They are standing here as they are operating. I'll show you now in there. This is a typical example of what I'm talking about. You can see the cutter there. That's the cutter as it is moving, and it is automatically advancing as well as it is cutting the face. And behind there, the golf is falling behind the guys. In another side view, the cycle there, typical roof support cycle. You can see the armored conveyor belt advance forward. Let me just reverse it. You can see there. Advance the shield, go up, and the golf falls down on the floor at the back. Golf. Here's another picture, the cutting drum, and it's moving across the face. There's a lot of coal coming out there. You can see the guys where they are standing, and this is the cut another angle, and there's the conveyor belt. So it's cutting, and that coal is falling into the armored conveyor belt, which takes it to another conveyor belt system to take out of the mine. You can see there. You can see all the coal that has been dropping on the armored conveyor belt, and you can see the protection for employees. So behind here is your golf that is falling behind you. There you go. And the armored conveyor belt from the machine feeds into this conveyor belt, which takes it out. You can see there's stone dusting, which we're going to explain, and whitewashing and all that, because it's dark, you need more illumination. So what are the main hazards in coal mines? 3 main hazards. This is your objective number 5. Fall of ground, roof and pillar collapse. That's hazard number 1. We're going to also look into those in a bit of details. Methane and coal dust explosions. Yes, it's coal. It's called methane, and the coal dust itself is quite dangerous. You have that as well. And transport, in terms of machinery and conveyor belts, where they use if you've been, take for example Middleburg Arnold, you see a conveyor belting system from the power plant right across N12 to the workings on the other side. It can be kilometers and kilometers of conveyor belt. So that can be very hectic indeed. So those are the 3 main hazards: fall of grounds, methane and coal dust explosions, and transport. Let's look at fall of grounds. Safety precautions against fall of grounds in the coal mines involve using proper support, or properly approved support, and continuous bearing down. And we have also discussed in earlier installments what is bearing down to remove the scaling. You can watch the coal mining video clip. You see people bearing down, removing scalings with a crowbar. Proper mining methods also assist in preventing fall of ground, because you don't want to be drilling and blasting within it. They follow a pattern the miners know to prevent such. And good supervision is always the remedy in preventing some of the accidents we get in our mines, and awareness and training on the hazards involving rock mechanics rock strata control and all that. That's what we are talking about here. Now, in terms of fall of ground, they use different types of supports in the coal mines. Pillar support, which is primary support. Remember, when they cut out the pillars, they're leaving the pillars in place. And this reminds me of a very the worst ever mining disaster we have had, a coal mining disaster and mining disaster overall we've had in South African history. Maybe you've heard about it. It's known as the Colebrook mining disaster. And I think they say it killed 435 employees at once underground. The Colebrook, there in the Vaal. People were underground doing their normal shift. And as you know, in pillar extraction, you cut out using your CMs or whatever. You cut out the pillars and you leave some sections standing. Because that acts as a primary support. Then you can come and extract those and let the ground fall as you are exploiting the coal that you have left in the pillars. So I'm sure in this disaster, when they were advancing, they were extracting too much in terms of ratio of the pillars they were leaving and what they were extracting. So one of the pillars collapsed, and you can imagine when one pillar collapses, it's a ripple effect. The whole mine went down, and there were 435 people who were buried alive in that and killed in that disaster. Till today, you go there is a monument. That's one of the mining disasters ever we have experienced. There are other coal mining disasters across Africa. In Africa, remember the Zimbabwean one, I think it was 1974-76, killed about 800 people. It was a coal dust explosion underground. Okay, it killed people. 700 to 800 people were killed. I remember that. There was the worst ever in the world, somewhere in Siberia, Kazakhstan, Russia, the former Soviet Union, 1913, if I'm not mistaken, or 1903. It killed over 1,000 employees. Coal dust explosion as well underground. So yeah, roof bolts, timber props are some of the support systems that are used. Chocks and shield for short haul and long haul. Wire mesh and lashing. Wire meshing, when you in the haulages, we put roof bolts and we lash with wire ropes, and then we put wire mesh like fencing, so that any loose rocks are kept intact. It's part and parcel of that support. Then we talk about methane and coal dust explosions, which I've already explained in terms of some disasters we've had. The only way to deal with that is good ventilation in a mine, watering down and dust suppression systems. Stone dusting is a system used in coal mines. It has helped a lot, whereby if you look at an explosion of coal dust, I'll show you now in the Kloppers Boss test in Pretoria. They do test there just to show you how dangerous coal dust is. Remember, there must be an ignition. Okay, in that ignition, the methane gas is burning and exploding, and is burning, and as it is burning, the coal dust is exploding at the same time. So you have the flame in front. If you take a camera of this blast, you have the flame in front, and then the back you have your coal dust exploding and the exhaust. And around it you find that there is the shock wave, because it is disturbing the atmosphere. So with stone dusting, what happens is they put across the haulages, or across haulages, cross cuts, you name it, they can hang balloons of stone dust. It is dust made out of an inert rock that is ground, that is inert. It means it doesn't have any chemical reaction, and they put those traps there. If an explosion comes through, okay, that force, the shock wave actually breaks those balloons and throws the dust up in the air. Or even if there's stone dust at the haulage, that explosion will throw the dust in the air. The dust sits on the coal dust particles and prevent the spread of the explosion, so to speak. That's what stone dusting is utilized for. Flame-proof equipment, yes, equipment. Also explained. Take that look at the coal mining video clip, and you will see what we are referring to. Flame-proof equipment is simply putting equipment that can ignite in those environments in containers, specific containers. Mostly people who maintain these are electricians, because they're the only ones with the spanners and the gauges that are allowed to touch this kind of equipment during maintenance, or to open this kind of equipment. You'll find it's just putting, say, a welding machine inside a container with a lid. Now on that lid, they leave a specific size gap around it. So if there's any explosion in there, it doesn't escape going outwards. It is contained in the container. So that's flame-proof equipment. Even the illumination lights, the types of lights that are used underground in coal mines are flame-proof as well. There are specific types. So this is what is called the Clopas Boss, to deal with, to show you how dangerous coal dust explosion and methane gas explosion can be. This is in Pretoria, 200-meter test tunnel. I think this is about 2.5 meters in diameter. This pipe, 200 meters long. So they ignite a bit of coal at the end there. You must listen and hear that thing moving and exhausting out there, and you understand how dangerous coal dust is. You can go and watch this in Pretoria, Clopas Boss, but I think it is for free, but you must do prior booking to go and witness those experiments. I think you can also look at this short video clip of what we're talking about.
Now, because the flame from methane is sort of bluish in color, you will mix it against the background. So we spread 1 kilogram of coal at the tip of the tire, just to color it. This.
Yeah, something wrong with the volume in this clip. But let's just watch the explosion going through. Okay, so that was just a kilogram of coal dust in there, and you can see the results. Okay, and this is just a shorter tunnel, and on the next beside this is the longer tunnel beside it. So you can see if that happens in an underground mine, what will happen to the rest of the mine. Okay, let's look at transport. In terms of transport, we use different types of transport. Shuttle cars. We need to check on the shuttle cars the condition of the cars itself. Does it have the lights, the brakes, the tires, and the whistle or the warning system, the gong to warn people around it, because it's always when it's moving there's that gong sound to warn people around it. The trailing cable I was mentioning, that you must be careful on shuttle cars. In terms of the condition of the cable, is correct anchoring and correct spooling or routing, because remember it is always behind the CMs. Tipping procedures, where the shuttle cars go and tip, must be adhered to. Stop signs must be adhered to, whistles, and also take note of the tip attendant. The drivers must be trained as well in everything that is for mobile equipment in a coal mine, and other persons on what behavior to be in when they approach this kind of machinery. Because these massive machineries, normally, almost always, as we said before, any accident involving these kinds of machinery can result in actually serious and fatal accidents, fatal injuries. Remember, other persons here, the trailing cable here, must step on it and straddle it. So the different types of transportation, again, conveyor belts, also dealing with one of your objectives. What checks do you do on your conveyor belts? We've touched this as well, even in underground fires. The guards are in place, sequence interlocking, emergency stop, firefighting equipment available, communication system must be available as well. And during inspections, you can check up for your build-up of DAF, dust suppression systems, belt structure, what is the condition of the eyeglass, the rollers, the strand, and the stands, the belt alignment, is it running in the middle of the structure itself, operators tools, no TPs, locks, PPE. Here we are talking about no TPs in terms of tools that operators are using on a conveyor belt. Normally you find they have shovels. The shovel must not have that handle where you grab, because if that shovel is pulled into the machine, the person is also pulled. So mostly we cut off that handle and it is just a straight shank. That's what we're talking about for those shovels and tools around that conveyor belt system. General cleanliness and tidiness. This brings us to the end of this installment. Any questions, ladies and gentlemen? Thank you very much.